Okay, let's create a shallow immutability class example. This is the class. Now let's add a small private field calling the name, another private final, a list of string. Now let's declare the constructor with some argument string name and a list of string items. In this constructor you have a this.name that we assign the name, and the other one that we assign the items. And let's import a list. So in the constructor we notice that items field we have a reference to the mutable object. Let's continue to the getter of the different method. Get name, another getter for list of string and return an item itself. Here on this getter of the list of string item we have the list of item itself. So in this example, the shallow immutable example class is immutable because its field cannot be reassigned. However, the items field refers to a mutable list. This means that while the reference to the list itself cannot be changed, the content of the list can be modified. Then, now, to demonstrate the behavior of the shallow immutability, let's create another class. Is it main? Yes. And let's declare the main method. Public static void main. And inside this main, let's declare the list of string. Call that variable items. And inside the variable we initialize it with a new array list object. In that items we add some object and call this items 1. We can add another one calling item 2. So now we can instantiate the shallow immutability class example, calling it example. In the first argument example, and in the second argument we assign this list of string that we created, and let's put the semicolon. Now let's display the content of class before to update it. Something like before modification. Now let's update the item itself. Now we add another item in the item list, items 3. And now we display that object again. Display the object after the modification. Let's try to run the main class itself to see the behavior. Before we have to compile the different classes we created. javac up done. Okay, let's go inside the CSC folder to make it simple, and let's run the main class. Now from the result we can see that we have here, before the modification we have items list, and after the modification the item list itself has been updated. So as you can see from the result, the state of the shallow immutability example object has been effectively changed because the mutable list was modified externally. From the understanding of the shallow immutability, it means that an object is considered shallowly immutable when the object itself cannot be modified after creation, but its internal references can still point to immutable objects. In other words, the immutability of the object does not extend deeply to the object it refers to. This contrasts with deep immutability, where an object and all the objects it refers to are immutable. To understand the difference, let's create another class for the deep immutability. To make it simple, let's create the deep immutability example class from the shallow immutability example class. And put the name deep immutability example. Let's change the name here, immutability example, and change the constructor name to deep. And here come the difference with the shallow immutability. For the deep immutability, we are going to make a deep copy of the list instead of reference to the immutable object. So it means that here we are going to assign a new array list of the item, and in the getter of the field list of string, we are going to change it because we want to use an immutable view of the list. So instead of returning the list like this that we did on shallow immutability, I'm going to create a collection of unmodified list of the item. Then now, as you can see, to achieve the deep immutability, we need to ensure that a field that reference immutable objects are deeply occupied, and expose a reference to immutable objects are either immutable, wrapper, or copy from this line. Now, here is how we can demonstrate the behavior to completely get the difference with the other one. To do that, we are going to update the main class. So instead of instantiate the shallow immutability class, we are going to do it on the deep class. Then now we are going to display the content of this object before the update statement and try to display the object itself again. Now let's run our main application to see the behavior when we are using the deep immutability example class. Let's compile every class again and let's run our main class again. Now we can see the difference here. Before the modification, we have 2 items inside the list. After the modification, we still have 2 items inside the list. You can see in the code we add another item, and this item was not taken in consideration. So now, in summary, we can say that 1. Shallow immutability ensures that the reference of an object field cannot be changed but does not protect against modification to mutable object they point to. And secondly, the deep immutability goes a step further, ensuring that the entire object graph is immutable. Third, in Java, achieving deep immutability often requires making defensive copy and exposing immutability views of mutable objects. Understanding the distinction between shallow and deep immutability is critical for designing robust, thread-safe application. Now this is the end of my presentation of the topic, what is the shallow immutability in Java programming language. I can say thank you for your watching and see you next time. Happy coding!